The Rocketeers, known as O Canada, were aiming for the record books this past summer. They wanted to launch the biggest, heaviest, and most powerful amateur rocket ever. And Daily Planet was there.
Welcome to Rock Lake. This is our 6th annual high-power rocket event here in southern Alberta. Over the course of the next 2.5 days, we anticipate seeing a total of approximately 250 rockets being flown by approximately 75 different registered flyers. Of those 250, 125 will be model rockets, and 125 we anticipate being high-power rockets.
By attracting members of rocketry clubs across North America, this event allows enthusiasts to get together and show off their wares.
I traveled about 650 kilometers all the way from Edmonton, Alberta, just to be here.
Keen first-timers also made the trip.
My rocket.
As did those known as altitude junkies, who are out to set new height records.
It's simmed altitude, computer simulation, say 20,000 feet at 1,950 feet per second.
Some just want to see the fireworks.
Low and slow. I want fire and brimstone on the ground, and I want everybody to see it.
While yet others are going for advanced certification from the Canadian Association of Rocketry in order to launch bigger and bigger rockets.
Yeah, that was pretty big. But wait till you see what we have.
Meet Team O Canada. They're here to make history.
Well, this here is the Dauphin. It's Canada's largest amateur rocket. It's 16.5 feet long, 22 inches in diameter with a 6-foot fin span. It's going to weigh about 300 pounds when it's totally loaded with all the fuel and propellant.
The Dauphin is a full-scale replica of a 1960s French meteorological rocket. To keep costs down, it was built mainly of cardboard, plywood and aluminum.
We spent probably around $1,500 on the airframe itself. I mean, it was one of our goals to keep it fairly cheap, fairly simple. Doing that, we've had to find some innovative techniques to make sure everything was going to be able to support 2,400 pounds worth of thrust.
One innovation the team had to come up with was fitting the largest industry-certified rocket, known as an O motor, into their homemade frame. In rocketry terms, each letter of the alphabet requires an exponential increase in power. So one O motor equals about 16,000 hobby A motors.
Okay, Scott's opening up the thrust plate hole a little bit to accommodate the outer diameter of the O. We undersized it slightly because the thrust ring is very small on these things, and we want that tight fit so it doesn't go flying through the inside of the rocket.
Two other engines, known as L's, are fitted next to the O motor, bringing the total thrust to 2,400 pounds. That's equivalent to launching a Clydesdale into space. But just as important as sending their rockets skyward, so too is bringing their craft safely back to Earth. That task falls to the brains of the aircraft.
So these are two of our what we call avionics pallets, and each pallet has two flight computers that take acceleration data as the rocket's climbing and measures difference in acceleration, stores that data. When it gets to the top of the flight, so it stops flying and starts falling, avionics will sense that and trigger some charges that will break the airframe apart and deploy the parachutes. On the way down, the flight computers then start sensing barometric pressure, and at certain specific altitudes, they'll also fire off charges.
Okay, well, you saw the avionics, which was the brains. I guess you could call these the brawn.
These canisters contain different amounts of black powder required to separate the nose cone from the airframe. Once the charges are placed inside, parachutes are placed in the piston bays. Then it's just a matter of assembling the body.
Well, the unknown factors depends on how the rocket comes off the rail. If we have a motor failure halfway up, if one L lights and the other one doesn't, we may have a little veer off on the flight path. The other ones will be whether the nose cone separates. If it doesn't separate, it's going to come in hard.
You might wonder why someone would spend 8 months working on something that may never leave the ground.
Why do we do it? To do it.
But for any launch to be successful, the weather must be on your side. Dave and his team can only hope tomorrow brings the same ideal conditions. But it was not meant to be. An early morning windstorm nearly destroyed the rocket and has put the team on edge.
Came by here and the rocket was on its side. So we're going, oh no, the fins are broke or something like that. So I'm sitting out here yelling, getting the guys out and things like that. So we get the rocket righted up and it's just pouring rain outside.
With the rocket still in one piece, Dave and his team can only hope the weather holds.
The hold right now is Ian getting off the phone.
This is Ian Stevens calling from the Lethbridge Rocketry. Looking for a winds aloft forecast and current. Okay, excellent.
The clouds are sitting at 6,000 feet. Our rocket's only planned to go about 5,800, but we need to have a margin of error. So until the cloud ceiling goes up to 7,000 feet, we're on a hold.
Regardless, Dave and his team head to the launch pad to try and control what they can.
We've got no current flow through there. We get continuity checks, but no current flow. Don't worry about it.
The controller at the M pad wouldn't be enough?
Hey, oh, I didn't hear those clicking before.
Despite the minor emergencies, Team O Canada perseveres and even gets some breaks.
It's dry.
It's dry. Woo! Yeah, we got it, we got it, we got it. Great. One more disaster averted.
It's now or never. Dave gets the team back to a safe distance. All they can do is hope for the best. If successful, they will set at least 5 Canadian Association of Rocketry records.
Okay, people, this is definitely a heads-up flight. Looks like everyone's standing anyway. We're going to go for a 10 count on this one. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
$17, $18, $19.
Yeah!
1 shoot! Yeah! 2 shoots! Yeah! All right, guys, congratulations! Yeah! All right.
Way to go!
Yes. Excellent.
Though the data will need to be closely examined, the onboard computers already tell Dave their mission was a huge success, despite a rocky landing.
381 feet per second maximum speed, or acceleration, 431 feet per second maximum speed.
Absolutely beautiful.
We broke the record. Multiple records here. Unbelievable.
As Dave surveys the damage and enjoys the moment, he already has his eyes on the next project.
What's next? Bigger ones, faster ones, higher ones. That'll be down the road. We need a drink.